Good day, fellow. I just want to explain two concepts today, ne? But more I'm going to focus on another one. Those are firstly physical changes. We have a physical change and a chemical change. Chemical change. Just want to explain these two concepts. That if we take for an example a solid ice and allow it to melt, it will turn into H2O, but of a liquid phase. Bear in mind, the phase is still the same. Sorry, not the phase. The identity of that H2O is still H2O. But the only thing that has changed is what? Its phase from solid to liquid. Now check. If I take now H2O, then change it into 2 and O2, then now this one is no longer what the physical change. This one is a chemical change. Why do we say so? Because now the identity has changed of what? Of that substance, in this case, which is water. It is no longer water. We have hydrogen as well as oxygen. Let me balance everything. See what I'm going to do. I'm going to put 2 and okay, let me put 2 this side. Yeah, the identity is the same, but this side the identity is no longer the same. See, it has changed now into other forms. See, we have reactant and product now. See, this one is still the same. I'm going to explain the concept of chemical change now using these 3 concepts. Firstly, we are going to start with the law of conservation of mass, which states the total mass in an isolated system is conserved. Check. What are we going to do now? From our periodic table, if you can go to a periodic table, you are going to see elements. You see their symbols, which is hydrogen, and we have a number here, which is an atomic mass. We have this number, which is an atomic mass. For hydrogen is 1. We want to use this number to calculate the molar mass of 2H2O in this given what equation. Then we also have of oxygen. The atomic mass of Earth is 16,0. This is your atomic mass. And how are we going to do that? We are going to consider now the atomic mass now of what? 2H2O, which is going to be 2 you write these 2 outside the brackets, then we have 2H plus 1. It's not 0, it's oxygen. See, it's not 0, it's oxygen. Then let us substitute our atomic mass. We have 1.0. I'm still focusing on this one, plus 1 of oxygen 16.0. Then we do have our calculator. Let's see, what are we going to get? We have 2, 1 plus 1, 16. We get 36. We get 36 grams per mole. See, let us see if we are still going to get the same thing for our product. For our product, this was for our, let's say in bracket, reactant. You see, let's see if we are still going to get the same thing for our product. Going to say now, for our product, I'm going to take of this whole thing now, which is 2. Just need to open for hydrogen, only have 2H plus 2 what? Oxygen. Let's see what are we going to get. You take this 2 out for this hydrogen, then this 2 is that subscript 1. Then we know that for hydrogen it's 1,0, close the bracket, plus 2 of oxygen 16.0. See, I hope you can see. Don't confuse these two. This 2 is this one. The other one is for this hydrogen. Then this 2 is for oxygen. You see? Yeah. Let's move. Then this side we are going to get 4 plus 16 times 2, get 32, and 32 plus 4 we get 36. See, at this point we have found the molar mass now of what? Of our product. Then what conclusion can we now draw at this point? You see, we have the same number, the total mass of what? Of reactant, total mass of reactant is equals to total mass of the product. You see, so simple. Then now I'm going now to explain another law, and let me erase quick so I can now explain another law. Let me not erase this. Oh, let me just erase it so that I can have much space. Now we are going to focus law of conservation of what now? Of atoms. Let's say atoms. It states now the total, let me say atom. atom. Total atom in total number. Let me see. Total number of atom in an isolated system is conserved. Check. We also have our reactants like before. I'm going to use this example throughout, which is now on our reactant side. If you can clearly look, we have 2, 2, 2, 0. From this given diagram, don't forget that if we don't have a number here, you just need to know that we have ghost 1. See? Then what are we going to do now? We are going to figure out as to now how many hydrogen do we have from this. You just need to take this number and multiply it with this number. We get 4. 2 times 2 is 4. Then for oxygen, I said we have 1. You multiply this number with this one. We're going to get now 2. See? So simple. Then let us check on our product side now. Product side. It's like this. We have 2H2. And let me write this plus 2. How many hydrogen do we have now? We have 2 times 2 is 4. Then oxygen, how many oxygen do we have? Just 2. See? 2. Because here we have 1. It's like 1 multiplied by 2. At the end of the day, we get 2. Then at this point now, we can then draw what? The conclusion to say, okay, on our reactants, we have 4 hydrogen. Same applies, we have 4 hydrogen on our product side. Same applies if I look for oxygen, I get 2 on our reactant. Same applies to our product, we also get 2. Then what can we say now? That total atom of reactant equals to total atom of product. Then the law of conservation of atom, it is fulfilled. Lastly, as for this one, I'm just going to explain it. The last one, I'm just going to explain it, which is the law of conservation of energy. The law of conservation of energy states the energy cannot be created nor destroyed, but can be transferred from one form into another. You see, somehow it is also conserved. If we take now this formula, sorry, this equation of water. Before we had water, but after we had what now? The hydrogen as well as oxygen. What happened in this equation is that the water molecule absorbed energy. The water, it has absorbed what? Energy that caused its bond to be broken down. You see, such energy we say it's endothermic. The endothermic. That's where now the energy is absorbed to break the bonds of what? Of water, in order to form what? This hydrogen as well as what? Is water. Then that energy absorbed, we call it what? An endothermic now. From the surrounding, it is absorbed so that it can break the bonds of water. Afterwards, we get a situation whereby now we have hydrogen as well as oxygen. Then when we break these bonds, somehow they are then going to form, you see, this side we break a bond, this side the new atoms are being formed. Then the energy now will be released. The energy will be released. It will release energy. You see, they will release energy. Such we say is exothermic. You see, somehow the water molecule has absorbed enough energy to break the bonds to form these two. Then these two, what is going to do is going to release that energy in order to be now H2 as well as O2. You see, that's what I wanted to ask, that the energy is not destroyed like that. Instead, this one absorb, this one release. You see, it is not created or destroyed. Somehow this one absorb, this one release. Hence we say that the energy is not created or destroyed, but it is absorbed where? From our surrounding. Then it is also released where? To our surrounding. Thank you.